Hello again, this is Mr. B. Hill. Today we're going to be talking about graphing in standard form. And we're just going to work through a little example here. We've got this standard form equation, 5x plus 8y equals 20. Of course, it's in simplified standard form, a is positive, and we have our three constants here, or the coefficients of x and y, and the constant 20 are all relatively prime. And the big idea here is that it's really easy to find the intercepts when you have a standard form equation. And let's go through why. So first off, we know the x-intercept, where the line intersects the x-axis. Well, the y-coordinate of any point on the x-axis is 0. So if we take this equation and replace the y with 0, the x will have to be the x-intercept. So basically we have the idea that the x-intercept occurs when y equals 0. Meaning that 5 times the x-intercept, I'll just abbreviate that int, plus 8 times 0 has to be 20. Now all we have to do is then solve for the x-intercept. Of course, 8 times 0 is 0. So that thing just goes away. So we have 5 times the x-intercept of the line has to equal 20. And of course, we'll just solve for that by dividing both sides by 5. Because then 5 will cancel. And then, really easy, the x-intercept of our line has to be 20 divided by 5, which is, of course, 4. So that gives us 1 point on the line. A really nice easy point, 4. Or actually the point would be 0, 4. Excuse me, 4, 0. Sorry. X's coordinate is 4. The y coordinate would be 0. And so, next, the y-intercept occurs when the x happens to be 0. Right? Because on the y-axis here, the x-coordinate of every one of those points is 0. So we just replace the x with 0, 5 times 0, and that makes the y become the y-intercept. And of course, 5 times 0 is 0, so that just goes away. So we have x times the y-intercept has to be 20, and then we just solve for this y-intercept by dividing both sides by 8. And so the y-intercept of our line is going to be equal to 20 divided by 8, which would be, let's see, that's 5 halves. Or since we're graphing, it might be easier to think of this as either a mixed number 2 1/2 or 2.5. And there's our second point that we need to graph, because we only need 2 points to graph a unique line. So we just come over here to our grid. The x-intercept is at 4, so that's the point 4, 0 right here. And the y-intercept is at 5 halves, or 2.5. So that's 0, 2.5, right here halfway in between 2 and 3 on the y-axis. And then we just play connect the dots. Get out my ruler here, try to be pretty neat about it. And there is our line, given by the equation 5x plus 8y equals 20. Now, if we want to just make sure that we did this correctly, just for a little bit of extra assurance, we'll check this. And what we're going to do is we're going to convert the equation to slope-intercept form. And that's really easy to do. All we do is we solve the equation over here for y. So we take our equation, 5x plus 8y equals 20. We've got to undo what's being done to y in reverse order of operations. So we've got to undo this adding 5x first. So we'll add negative 5x to both sides, or subtracting 5x, but that's the same thing. I like adding negative 5x because it's commutative, and now we can switch this around if we want to. Those go away, and we have 8y is equal to negative 5x plus 20. And then we'll just divide both sides by 8, because these 8's will cancel out. Then, of course, we'll have to distribute this dividing by 8 to both terms in the numerator. So we have y is equal to negative 5/8 x plus 20 divided by 8, which was 5/2. And then we immediately see the y-intercept of 5/2. Oh yeah, that's what we had over here. Now the slope is a little bit different because it's in negative 5/8 here, but we could kind of figure it out here. Or, heck, let's just use the calculator and punch this in. So you can see that. Y is equal to negative 5/8 times x plus 5/2. And we can just graph that. And as I have my window changed up a little bit here just so it's easier to see, but it looks like the x-intercept is at 4, the y-intercept here is in between 2 and 3, but hey, this is actually kind of a nice little trick here. If we go to zoom, what I did there was I went to zoom, and then this zoom decimal is a handy little feature, because it puts 1 pixel every 10th on your graph. So when we graph this, when we hit trace, see where our cursor is at? Oh, it tells us what the y-intercept is right here. X is 0, y is 5/2. Wonderful, that's exactly what we wanted. Right? 5/2 is 2.5. And if we scroll way over here to where the x-intercept is at, we see very clearly, oh yeah, here we go, when x is 4, y is 0, so that's the x-intercept of 4, which we had right there. So we did it right. Fantastic. So, of course, I shall leave you with a couple of practice problems. Do those now. Find the intercepts of each of these equations, and then graph them from the intercepts. You might want to check yourself by converting them to slope-intercept form and seeing if that graph is correct in a graphing utility. So do those now. Don't wait until class. You're supposed to do them now. This is homework, so you're ready for class with these graphs. Seriously. No, do them now. I'm dead serious here. Do them now. Very clearly. Show all work. If you mess up, go back and rework them. Do them now. See you in class.